Now, those thresholds that I mentioned kind of fall into two categories. There's static thresholds, and static thresholds allow you to watch for high and low watermarks, right? So they're basically allow you to look for if this particular statistic is over this value for a particular period of time or under it for a particular period of time, we can generate an alarm based on that. And those time periods are critical because that's what lets us kind of blunt out false positives. So the idea being that if I've got a SQL server, it hits 100% CPU utilization 15 times a day. That's no big deal because that's what it's supposed to do. I don't want to get paged every time that happens. So instead, I'm going to set a time period to a longer period of time because maybe I don't want to get notified when it's over 90% unless it stays there for 15 minutes or for half an hour, because that I know means I've got a job stuck that I need to go take a look at. So that's one way you can use the threshold timers to adjust the granularity of the alerts we're sending out for it. Now, with thresholds, we only generate alarms when you cross that critical threshold point. We don't generate alarms for warnings. They will show up on the dashboard, but they don't generate notifications when you're talking about thresholds. Now, we check our thresholds every 5 minutes, regardless of what that time period is set to. So if you're setting a 15-minute time period, for example, in this example, we've got a 65% over 15 minutes. You could cross that by being at 66% for 3 consecutive polling cycles. So you've got 15 minutes of just over 65%. But you might also cross it if you were, let's say, running at 50%, and then the very next sample was 99%. That might drag the 15-minute running average up over the critical threshold level and generate that notification faster. So keep that in mind. It doesn't mean you have to be, over that number for the entire time period. It just means the average has to be over it, for that entire time period. So you can use that to kind of tune them as well. Now, the second kind of thresholds that we consider anomaly-based thresholds. And anomaly-based thresholds are configured as a percentage of deviation from previous values. So these can be compared based on the time frame to different types of thresholds. So if I'm looking at this, for example, as rate of change, I can say, look at this 15 minutes versus the last 15 minutes, and just tell me if there's a sudden change in the value. But it can also be compared to a previous date and time. So I can, let's say, is it the same yesterday at the same time or 7 days ago at the same time, on the same day of the week, and is it significantly different between those two time periods? That time period, the anomaly time period here, allows you to do the same kind of tuning that you would for thresholds, where you can blunt out sudden spikes so it doesn't trigger an immediate anomaly alert just because you get a one-time spike in the data. You can kind of average that out to blunt the way the comparisons are done and make sure that you're not getting false notifications. Now, the other thing to be careful of with anomalies is because they're set as a percentage, really low values can have strange results. So if you're looking at a stat, for example, where the normal value of the statistic, maybe it's a CPU and it's running at 0.01%, or 0.001%, I can put a 1,000% threshold on that, but that still only means it's at 1%. So you can very easily, generate too many alarms with the anomaly values if you're not careful with them. So just something to be aware of.